Hello, my name is Andres Aldivar, and with my partner Luis Artemio Fernandez, we will be presenting the integrating project. So here is our final project. In the next image, you can see the area we're trying to find out using integral calculus. Here it is, shaded in blue. So now, the green line, as you can see, is equal to this formula, sine of 1/5 x plus 10. So let's start the problem to find out the area. So the integral of between the intervals 16.6 and 4.6 of sine of 1/5 x plus 10.
Well, now we will continue with the integral of the formula that will be, in this case, we will need to use a substitution method that will be u equal 1/5 of x du 1/5 dx will be du over 5. Then we will plug in, that will be sin u du over 5 plus 10. This will give us the integral that will be minus 5 cosine 1/5 of x plus the next. And the intervals will be 16.6 and 4.6.
Okay, so now, since we got the integral, we will plug in our intervals. So first, let's plug that in. -5 cosine of 16.6 5 plus 10 multiplying the 16.6, all these minus -5 cosine multiplying 4.6 over 5 plus 10 multiplying 4.6. We got to remember all this is subtracting all this, okay? So the equal of the first part is 161.0083917 minus the equal of the next part, 41.0064456. If you subtract all these, you will get the equal of 120.0077471 units squared. This is the exact area that is shaded in the blue part.
Well, after analyzing the results, we can conclude our results from the area below the curve was right, because the third approximation that we think it was the most approximate give us around 1.25 or 125, and when we did the formula it gave us around 120. So we believe this is correct, and getting to know that how big is like the square and the paint, we can notice that this conclusion was right and we were right.
So in this project, we learned that using the integral calculus is another evidence that math is everywhere. As we can see, using the formula, getting the formula and using it for getting the area in the paint we made in the other class, we notice it is actually correct, since using geometry, it is pretty close to the data we got using the formula.